All right, class, yesterday we worked with the idea of multiplying and dividing radicals. Today we're going to look at the idea of adding and subtracting radicals. Now, if you look up here, I've got this problem and it says use the distributive property to show y. Now, if we looked at this back in chapter 3, we would say, oh, Mrs. Burton, you just collected like terms. Now, how we used our distributive property, if you remember, we just went ahead and we pulled the coefficients out, okay? And then we just went ahead and did the math with the coefficients. 9 plus 4 is 13x. And so that's what we did. So we're going to see this idea of working with adding and subtracting radicals. We have to have like radicals. And if you think a lot about it being the idea of like terms, it will help. Kind of like if I had 9 apples plus 4 apples, I would get 13 apples. And so we're going to see with that in mind, how would I use the distributive property to find 9 root 5 plus 4 root 5? That's right. We're just going to take the coefficients out in front because they're like terms and do what the operator says. 9 plus 4 is going to give me 13 root 5. So remember, for me to have like radicals, what's inside the radical, what's inside the house, has to be the same. They have to be like terms. So with that in mind, if I gave you this equation right here, okay, is that equation in simplest form? So let's look. Are they like radicals? Well, no. We've got the square root of 3 here and the square root of 2 in the other one. They're not like radicals, so I can't put them together. So the answer is yes. Okay, the answer is yes. That binomial is in simplest form. I cannot put them together, okay, cannot add them because they are not like radicals. So let's see what that means for us as we try to work with these radical problems. We're going to see to simplify sums or differences of square root radicals. First, we've got to express the radical in simplest form. Now, we've been doing this since the beginning of chapter 11. And then we're going to use our distributive property. We're going to add or subtract, do what the math operator says with the coefficients that are there. So let's look at number 1. I definitely don't have like radicals. I've got square root of 80 and square root of 5. But I've got to simplify the square root of 80. Well, if I simplify that, they kind of give me a hint. There's a 5 in that radical. Will 5 go into 80? Sure will. We get 16 times 5. Okay? So the square root of 16 is 4. 4 times the 5 out in front give me 20 root 5 minus 12 root 5. Do I have like radicals now? I do. So we're just going to use the coefficients out in front. 20 minus 12 is 8 root 5. Let's look at number 2. Well, I don't have like radicals, but I'm going to have to simplify 24, and that's going to be 4 times 6. So the square root of 4 is 2. 2 times the 2 that's already out there is negative 4 root 6 minus 3 root 6, which gives me negative 7 root 6. Now, because we're adding and subtracting, we're going to have positive and negative numbers. Integers are back, so make sure you remember your integer rules. Let's go ahead and look at number 3. When I look at number 3, okay, I can simplify the radical 45. We're going to make that 9 root 5. Wow, but when I get over here, did you realize that's a perfect square? What's the square root of 36? 6. 6 times the 7 that's already there is 42. Can I add those numbers together? You're right. Okay, they're not like terms, so I cannot add them together. So that's my final answer. Okay, final answer right there. Okay, let's look at number 4, the last one on this slide. Now, do you notice we're going to have to simplify both of our radicals? This is going to give me 25 times 3. And so the square root of 25 is 5. 5 times that negative 4 is negative 20 root 3. Now, how are we going to simplify 147? Well, since I've got a 3 left in the house here, does 3 go into 147? Sure does. We're going to get 49 times 3. The square root of 49 is 7. 7 times that 3 is 21 root 3. And now we've got like radicals. Negative 20 plus positive 21 gives me positive 1 root 3. Now, you wouldn't have to put that positive 1 there, and it would still be okay. So we realize, hey, I'm going to have to simplify some radicals to get like radicals so I can add or subtract. Okay, let's look at the next one. Okay, so if I look here, okay, I've got to simplify some radicals. So 72, remember Mrs. Burton said the best one to remember for that is 36 times 2. It's my perfect square, so we're going to get negative 18 root 2. Now, this one, let's see. 2 goes in there, but that doesn't help me. Does 4 go in there? Yeah, it does. We've got 4 times 13. So square root of 4 is 2, so that's going to give me 12 root 13. And when I look over here, well, 2 goes in there. Oh, 2 works really nice because we've got 64 times 2. Square root of 64 is 8. 8 times 7, negative 56 root 2. Now, do I have any like terms that I can put together? Yeah, that's right. The root 2's are the same, so we can put them together. What's negative 18 and negative 56? I think it's negative 74, negative 74 root 2. And again, that 12 root 13 doesn't have anybody to combine with, so he just comes along for the ride. Now, when we look at number 6, our first problem child is the fraction, because remember, we can't have a fraction inside the radical, so we're going to make it the square root of 1 over the square root of 3. Well, 1's a perfect square, so I can simplify it to that. Now, we've got a radical in the denominator. We're going to have to rationalize the denominator, so we're going to end up with root 3 over 3. Now, what's understood in front of that root 3? There's an understood 1, so we can kind of pull the fraction out in front and say 1/3 root 3. Well, now I've got root 3 minus 1/3 root 3. Now I have like radicals. Hopefully you realize there's an understood 1 in front of there. What's 1 minus 1/3? Yes, we've got 2/3 root 3. Hopefully realizing this could be 3/3 if you needed to, because we have to have a common denominator to subtract. Great job. All right, now here comes the fun. Let's go ahead and see what we can simplify on number 7. Well, I know this is going to have to be 25 times 3 and then 5 times 2, so we've got 10 root 3 plus, we're going to have the square root of 3 over the square root of 16, but that's a perfect square, so I'm going to go ahead and put that 4 down there because the square root of 16 is 4. Now, we're supposed to add these, but the problem is I got a fraction. This is over 1, so we need a common denominator. Well, what does our common denominator have to be? Well, it has to be 4. So 1 goes into 4 4 times. 4 times 10 is 40 root 3. Okay, hopefully you understand how we did that. And then root 3 over 4. And now I have a common denominator, so we can add the numerators. What's 40 root 3 plus root 3? 41 root 3 over 4. Nice. Okay, now when we get to number 8, oh my goodness, I've got 2 radicals inside the house. So I'm going to go ahead and take those fractions that are inside the radicals and rewrite them as numerator over denominator. Wow, we're going to have to rationalize the denominator of the first one, and we're going to get the square root of 14 over 7. And we're also going to have to rationalize the denominator in the second fraction. So we're going to get the square root of 14 over 2. Remember, square root of 2 times square root of 2? All right, now, before I can add or subtract fractions, I have to have a common denominator. That common denominator's got to be 14. Okay, so 7 goes into 14 2 times. 2 root 14. 2 goes into 14 7 times. And so now we've got like radicals and we've got a common denominator. So what is 2 minus 7? That's right, we've got negative 5 root 14 over 14. Great job. Okay. Let's look at number 9. Now, when I look at number 9, the first thing I'm going to do, well, we've got the square root of 16 over 3. This is a perfect square, so we're going to have 20 root 3 minus, and then 9's a perfect square, 3 root 2. Now, did you notice we're going to have to rationalize both of those denominators again? Square root of 3 over the square root of 3. So we've got 20 root 3 over 3 minus, and then here we've got to rationalize. So we're going to have 3 root 2 over 2. And now I've got to come up with the common denominator. My common denominator is going to be 6. So we've got 6 goes into 3 2 times. 2 times 20 is 40 root 3 minus, and we've got to multiply that by 3. And believe it or not, I'm done because I can't combine them. I can't add them because they are not like radicals. All right. Let's go ahead and look at number 10. So when I'm looking here, okay, well, I can't really do anything to the first term. And then here, we're going to simplify this, and this is going to be 4 times 10. The square root of 4 is 2, so we're going to have negative 6 root 10. And then here we've got plus 5, and we've got the square root of 1 over the square root of 10. So once again, we're going to rationalize the denominator. And so we're going to have 8 root 10 minus 6 root 10 plus 5 root 10 over 10. Well, I think I'm going to make life a little bit easy on myself. 8 root 10 minus 6 root 10 is 2 root 10 plus 5 root 10 over 10. I got to get a common denominator, which is going to have to be 10. Okay, so this is going to be 20 root 10 plus 5 root 10 over 10. And now that I have a common denominator, and like radicals, we're going to have 20 plus 5 is 25 root 10 over 10. And now, did you realize that I can reduce that fraction right there? So we're going to get 5 root 10 over 2. My GCF here is 5. Okay, so again, when we're adding and subtracting, I have to have like radicals, like terms, and we also have to have common denominators. Great job.